All right. I can tell you right now, you're going to hear barking this whole time. But I'm out here and the dogs are outside and I'm out here in the back office. And so we're just going to do this with the barking. So sorry. Here we go. All right. So we want to talk about how to find percentages and percentiles of certain areas with context. Sometimes you're just going to do it with straight standardized scores, okay? And so here, let's go ahead and start with this. We're on day 2 notes. I guess that would be page 13 in your packet. Okay, so here we go. So we're going to do this mostly when we are comparing two different kinds of things. We've got apples and oranges here. And so they have different overall values. So you can see we have an apple that has a mean of 6 with a standard deviation of 1. Then the orange has a mean of 7.5 and a standard deviation of 1.5. All right, so let's go find out things about them. So first, we're going to talk about, I have an apple that weighs 7.2 ounces, and I have an orange that weighs 9.3 ounces. So what percentile are they in? And how can I compare apples to oranges? Well, with percentiles and with standardized z-scores, you can do that. And so that's the first thing. And we kind of talked about that a little bit at the end of the video yesterday, the second video for yesterday. So first, let's remind you about percentiles. If you're in the top 10%, then guess what? You know you are in the 90th percentile, because percentile is how much is at or below you. Okay, percentile is how much is at or below you. If you're in the top 10% of your height, then you are taller than 90% of your peers. All right, so if we want to compare this, so first of all, one of the things we will do, of course, is define the context. So this on the left, the X is the weight of the apple in ounces, and on the right, X is the weight of the orange in ounces. So the question was, what percentile is our 7.2 ounce apple in and our 9.3 ounce orange? Well, so what you can see here, you see I have the standardized scores here. Those are the z-scores, but look below. These are the context values with the mean of 6 and a standard deviation of 1. Okay, and so then there's where 7.2 falls. So remember yesterday, all of our values came down just on a whole standard deviation above or below the mean. Well, this isn't a whole number of standard deviations. It's 1.2 standard deviations above the mean. Okay, so not a whole number. Same thing with this one. So let's talk about how we're going to use Desmos to help us find that area. So here we go. Let's go to Desmos. So I've got this here. I have got two different things. First, I wrote normal dist. Okay, so normal and then dist. That's going to get you a normal distribution. And then parentheses, and then you're going to put the mean in first and the standard deviation in second. Okay. If you don't do anything, it defaults to a standard normal one of 0 for the mean and standard deviation of 1. So if I just did that, that is the standard normal one. So you don't technically have to put 0 and 1 in there to be a standard normal model. Okay, but there it is. Now, what we want to, and then you have this little section here that says cumulative probability. Okay, so let's take a look at those. So let's talk about this. This first one is the apple. Okay, so I have the apple. Let's find the cumulative probability and look at what I want to find here. I want to do the area to the left of a 7.2 ounce apple. All right, so because left is the area below, and so then that's going to tell you that percentile. So when I type this number in, see, look, if I type 6, that's at the mean. So see, that's 50%. but we were asked about a 7.2 ounce apple, okay? And then it comes up, this is the percent, and you have to, of course, move the decimal twice or multiply this decimal by 100 to get the percent. But I want you to do 4 decimal places. So, as you can see, you're only able to visualize 3 decimal places here, but watch this. If I click this little arrow, and then I click, you can see it there, but also I just like to usually click this right here, and it'll snapshot that and put it right here. So it's 0.8849, which that is why it shows 0.885, because it rounded it. So if you multiply that by 100, in fact, you could do that if you wanted to, times 100, then you have 88.49%. So you're in the 88th percentile, okay? But I'm hoping you don't need to be multiplying by 100 all the time. I'm hoping you're going to be able to visualize, move the decimal twice, and that's what you are in. That's your percentile you are in. Move the decimal twice. Please don't waste your time going typing times 100. Move the decimal twice. Okay, so I can see then that 7.2 ounce apple is in the 88th percentile. Well, let's look at our orange. Okay, so here I'm going to turn off this apple picture, and here's the orange picture. I'm going to zoom to that, and let's take a look. There, it had a mean of 7.5 and a standard deviation of 1.5, and we were asked about a 9.3 ounce orange. So if I've typed in a 9, we want left area. So we'll get that percentile, left area. Then that gives us the same thing. So if I hit this here with a copy and paste right here, same thing. Look at those 2 values. They are identical. So the interesting thing is, even though those fruits weigh totally different amounts, 7.2 ounce apple, 9.3 ounce orange, they are actually the same size relative to their own type of fruit. They are both in the 88th percentile of their type of fruit, okay? So not one of them is more remarkable than the other. All right, because remarkable will be like more amazing, more outstanding, farther away from the mean. Okay, so now, the top of the next page, this is the TI calculator information. I don't have that for you in terms of how you would do that on the Desmos. I don't have that typed out for you because we're just kind of doing it and having you remember it. So remember that. So here we have the same thing with the apple that was 72 ounces. It was in the 80th percentile. So basically we just did that. Ooh, but what about an apple that weighs 4.6 ounces? Let's go see what percentile that one is in. Okay, so here I go. I need to go up here to my apple information, and it said how much is a 4.6 ounce apple. Okay, I'm going to get rid of that. Copy this information down. So what percentile is this in? Remember, just so you can see it, I'm going to multiply by 100, but please don't waste your time typing that. So if I multiply by 100, I can see I am at the 8th percentile. So 8.08%, because I want you to round properly. So 8.08% of oranges are less than that. The question also was, why is that number less than 50%? Well, if you visualize a picture of what's going on, and so let's go ahead and do that here. If I go see this guy right here, okay, then look at what's happening. See, this is at 4.6. It is below the mean. That's why this area is less than 50%, because it is well below the mean. All right, and in fact, according to the lesson that we learned in the last video, we could do our little z-score formula and go x minus the mean over the standard deviation to see exactly how many standard deviations it is below the mean. All right, next, Now we're asked, because those said below. Okay, so how do you compute if you want to go above a particular value? So this next question, D, says, find the proportion of apples that weigh above 8.2 ounces. And then it asks if it's an outlier. Okay, so we'll talk about how we have to do that. So first, what's the area above an 8.2 ounce apple? So I need to be here on my mean of 6, standard deviation of 1, and I've got 8.2 ounce, but I don't want to go below it. I don't want to go left. I want to go above it. So I want to go to the right. See, so here this is. It's a much smaller area. In fact, look here, I'm going to copy and paste this down below. It is this number, 0.0139. And just so you can visualize it, if you multiplied it by 100, that is only 1.39% of apples weigh more than 8.2 ounces. Only 1.3% of apples, 39% of apples weigh more than 8.2 ounces. Okay, let's see what's next. What about an orange that weighs 6.2? We want to go, what proportion of oranges weigh above the 6.2? So I want you to look at how we didn't do the second part of that question D here. Is it an outlier? Okay, do you remember our outlier rule? Outlier rule means you are more than 2 standard deviations above or below the mean. So I need to know how many standard deviations I am away from the mean. What did we just learn in our last video? That was the second part from yesterday's stuff. How do I get the number of standard deviations I am away from the mean? I get a z-score, and that's this right here. I'm going to go x minus the mean right here in this area. X minus the mean over the standard deviation. X minus the mean over the standard deviation. And that's 2.2. So an 8.2 ounce apple is 2.2 standard deviations above the average gala apple. So is that, if you had an 8.2 ounce apple, is it an outlier? Yes, it's very unusual because it is more than 2 standard deviations above the mean. So it's considered unusual. It's considered an outlier. All right, so let's do that here with the orange. What's the proportion of oranges weigh more than 6.2 ounces? So take a look what that looks like a Desmos. We're down here with the orange information. With a mean of 7.5 and a standard deviation of 1.5, it said more than, what did it say? 6.2. Okay, we want to go more than, so greater than, that's to the right of 6.2. So I'm going to type that in there. And then, voila, there we have it. I'm going to do that. I'm also going to show you a picture of this. Look here. Because, in fact, if I typed in this little x equals right here, look here. X equals this. That's not right. That's because that's a percent. I'd need to get the z-score. Okay, well, we're going to save that for tomorrow's lesson. All right, but see, look, here is the 6.2 ounce orange, and there is 80.69% of oranges that weigh more than a 6.2 ounce orange. So it's down there in the lower 20th percentile. Okay, so it's underweight. See, it's below the mean. Okay, so what percent of apples, what proportion of oranges weigh more than that? Over 80%. Okay. All right, so that's what that question asked there. Now, why is it over 50%? Well, because 6.2 is down here below the mean. So it's the 50% to the mean plus a little bit more. All right, so now let's just make sure we know how to, oh, look, here's one other kind. How do you do this for the area in between? How do you find this area in between two values? So we have a apple, we got it at 4.5 ounces, and then right here at, what is that one, 6.2 ounces, and so what's that area in between? So look at how you do this notation. In fact, let's go back here. If you are going greater than, you're going to say this is the probability, right here, there's your P for probability, that you get an X, a context value, greater than or equal to 8.2. And then that equals, and you can write this as a decimal or you can write it as a percent. If you write it as a percent, make sure you have that percent sign. And so this one here is area in between. So look, I have my X, the probability of finding an X, a context value in between. So notice the inequality signs point to the smaller value, point to the left, in between 4.5 and 6.2. So let's go see, this is the apple again, 4.5 and 6.2. Okay, so let's see how that would look here. So what do you think we would put here? It is in between. So I want the cumulative probability of the inner area between, was it 4.5 and 6.2? Can't remember. I think that's it. And then I'm going to copy that down. So there it is. And here's my picture. Okay, so I have the shaded, this is the proportion of apples that are in between 4.5 and 6.2 ounces. So what you need to get used to doing, and this is one of the things we're going to talk about in the middle, is doing this probability notation, drawing a quick sketch where you label the values and the mean, and you shade that area. Okay, and so then here was another one. Find the proportion of oranges between the 7.8 and the so on. And so here is that notation. X is in between 7.8 and 9.8. And I went and I put that in for the oranges. So that's down here. Inner probability. What was it? Was it 7.8 to 9.8? Something like that? Okay. Let me double check that. And yep, 7.8 to 9.8. So that is a what proportion of oranges are in that area? 35.81% of oranges weigh between 7.8 and 9.8 ounces. Okay, so let's summarize what we got for Desmos. So let's kind of summarize that probability notation. So if you're going Desmos left, it's because you want the probability of a context value less than a value. If you're going to go above, you're going to do Desmos right, and you want the probability of X being greater than or equal to a value. And if you're going to go Desmos inner area, then you're going to do X is in the middle, and you want probability of the lower bound, X is in the middle, and then the upper bound. Okay, so that's how you write that. So now let's just finalize this out. What work do you show? Okay, so let's start from scratch. Here we go. What work do I show? Here we go. Everything. Let's do it. So number one, define what X represents. Define the context. First and foremost, what is this about? Context is math class. So then we're going to write our normal notation so we can define the mean and standard deviation we're dealing with. Then we're going to write the probability notation we want to do, and then show a picture. And then, of course, at the end, finally answer it. So let's go through that. First, find the proportion of banana bunches that weigh between 76 and 85 pounds if the mean is 74 pounds and the standard deviation is 8.5. So define X. What does X equal? The weight of banana bunches in pounds. The weight of a banana bunch in pounds. That's the context. Okay? Then do the normal notation. So in parentheses, the mean of 74 and the standard deviation of 8.5, okay? Number 3, write the probability notation of what you're finding. I'm finding the probability of X being in between 76 and 85. And then number 4, draw a picture here. You're going to want to do some labeling of this picture. I didn't here because it's kind of labeled, but it's really small. So you want to label this value here. You want to label this value here. It would really be good if you also put that mean in there so you can see what that, so put the mean and then the bounds and shade the area you want. Then you're going to go to Desmos to get your answer. So let me get out of this here. I'm dealing with a normal dist with a mean of 74 and a standard deviation of, 8.5? Okay, is that what it was? Yes, okay, good. And I want to go between 76 and 85, so here we go. So cumulative probability, I'm going between. So this is the inner part between, 76 and 85, something like that. Okay, and it is the area, and boom. There I have it, 30.92%. Make sure you round correctly. 0.3092, so that's 30.92% of banana bunches weigh between 76 and 85 pounds. All right, so there you have it. That's the things you have to show per problem. Here we go. Next. Here's the second one. This one is just saying find the percent above 83.6 if the mean is 86 and the standard deviation is 6.5. So here we go. Define X. I don't know what this is. It's just talking about data. Normal model with a mean of 86, standard deviation of 6.5. I want to go greater than or equal to probability of X being greater than or equal to 83.6. Draw a picture, okay, and put your, go ahead and do your little line here and label that as the 83.6. Go ahead and put your mean in there, shade. Then you go to Desmos and you put it in, and it came out to be 0.6440. And what's the last one? Is the weight of a wild hog in pounds. The mean of 210, standard deviation of 21. Normal model. Find the probability that you find a wild hog that weighs less than or equal to 256. I draw a picture. I go and I put it in there, and then the question says maybe what percentile is it in? It's in the 98th percentile because it is better than 98% of hogs. It weighs more than 98% of hogs. All right, that is it. I did just want to give you one quick little word of warning. Man, this this definitely was not written with the space for all the Desmos pictures and everything. But for numbers 1 through 5, on all of these, you are using the normal model because it's giving you information about a z-score. A z-score is on a standardized normal model. So for problems 1 through 5, you are using a normal model with a mean of 0 and a standard deviation of 1, okay? So just put that there. For numbers 1 through 5, we have a normal model with a mean of 0 and a standard deviation of 1. You can do a quick sketch of a normal model, but definitely you are writing your probability notation. I want to find this, but I want to do a z-score. And then I want to do less than or equal to a z-score of negative 0.66. So these are z-scores, not context, okay? Equals, and then go do this in Desmos, okay? So you're going to be going into Desmos, and you're going to be doing the normal distribution with a mean of 0 and a standard deviation of 1. And then you have we're going less than, so that's left, and you're going negative 0.66. So draw that picture and then put that number in there. There you go. That's it. So there you go. Do all of those. Practice showing your work and practice how to get your percentages, how to write those things. And that is it. So you are doing pages 16 through 18 on those. So good luck with that. It is a lot of practice, but it will go really quickly. You'll get used to doing it in Desmos and it'll go really fast. Okay? So good luck to you on that. And I will see you tomorrow when we go over this assignment.